Problem number 5. Zoe and Nick play 3 rounds of a game. Zoe is the more experienced player, so she has a probability of winning of 3/5. And the question is, what is the probability that Zoe wins for the first time on the 3rd round? Okay, so Zoe loses the first game, she loses the second game, and then she finally wins the 3rd game. So, well, my explanation of the solution to this will depend on how much experience you have with probability. So the easy way to do this, if you have some experience with probability, is to say, well, if Zoe has a 3/5 chance of winning, then she has a 2/5 chance of losing. So the probability that she loses on the first round is 2/5, and the second round she has a probability of losing of 2/5, and her probability of winning the 3rd round is 3/5. Okay? And all we have to do is multiply those together, and we'll get 12 125ths. Okay? And that's the answer. But if you haven't had the experience with probability, you may not automatically recognize that you can just multiply those probabilities together. So let me give you a little more detailed explanation of this problem. So, alright, so let's take a look at this. You might look at it as, well, Zoe could win or Nick could win. Alright? So it's sort of like a coin toss, but it's not like a coin toss because the outcomes are not equally likely. Alright? I mean, you could think of this as, heads and tails, but in a coin flip, your probability of getting heads is the same as the probability of getting tails. Or in this case, we have a 3/5 chance that Zoe's going to win, and a 2/5 chance that Nick is going to win. Alright? And so on. Zoe, on the second round, Zoe could win or Nick could win. Or, and if Nick won the first round, Zoe could win or Nick could win. And so on. Zoe, Nick, Zoe, Nick, Zoe, Nick, and Zoe, Nick. Okay? And the path that we're interested in is this Nick winning the first round, Nick winning the second round, and then finally Zoe winning. That's the probability that we're looking for. So there's, 2/5 chance that Nick wins the first, 2/5 that he wins the second, and then 3/5 that he wins the third. Or that Zoe wins the third. Okay? And that gives us our desired outcome. So, but one way you might think of this is, here we've got a case with where the outcomes are not equally likely, but we can sort of formulate an equivalent problem with equally likely events, or equally likely outcomes. All right. So let's say we had, 5 different. You can see we're working in terms of fifths. So equivalently, it's almost like Zoe has 3 ways of winning out of 5, and Nick has 2 ways of winning. Okay? Does that make sense? So this would give you if these were all equally likely outcomes, this would give you the same probability as up here, right? So you'd have 3 ways that Zoe could win and 2 ways that Nick could win out of 5, all right, on the first round. So, so you can see here that we have 2 ways that Nick could win, all right, because we're looking at, let's go ahead and just draw this tree down. This gets a little messy because we have 5, because we're formulating an equivalent problem. So instead of saying, Zoe has a 3/5 chance of winning, we're saying Zoe has 3 ways to win out of 5, and Nick has 2 ways to win out of 5, and each of these ways is equally likely. Okay, so if we were to draw this tree, and I won't be able to draw this whole tree because 4, 5, you have 3 ways that Zoe could win the second round and 2 ways that Nick could win, and we'd have 5 branches here for each one of these, okay? So that's why it gets messy here. But so you can see though, if I could draw. So again, on the third round we'd have 3 ways that Zoe could win, and 2 ways that Nick could win. Whoops. That Nick could win. All right. So Zoe, 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 and then Nick and Nick. All right. So if you look at this tree, you can see that we have, for the total possible outcomes, we have 5 outcomes for the first round, 5 outcomes for the second round, and 5 outcomes for the third round. Okay, which gives us 125 total outcomes. Okay, and again, this is an equivalent problem. All right, so we've just translated this problem with where the outcomes are not equally likely into something where there's equally likely outcomes, although 3 of the outcomes involve Zoe winning and 2 of the outcomes involve Nick winning. Okay, so we've got in the equivalent problem we've got 125 total outcomes, and you can see we have 2 ways of Nick winning the first round, 2 ways of Nick winning the second round, and then 3 ways of Zoe winning the third round. Okay, so this is the outcome that we're looking for, because we're asked to find the probability that Zoe wins for the first time on the third round. Okay, and again, if we just multiply those together, we end up with 12 desired outcomes. Okay, in this equivalent problem, which gives us the probability of 12 1/25. Okay, so given the fact that we have outcomes that are not equally likely, we can formulate this equivalent problem. Okay, and then you can see it a little better why we can just multiply those probabilities together. Okay, hopefully that makes sense to you. So there you go. There's the answer, 12 125.